Alright, question 11. We have a series of pairs of compounds, and the goal is to identify them, what their relationship is. In part A, we have a pair of cyclohexane rings that are fused together. And we can see that in the first case, they're cis to each other. And in the second case, they're trans. So what does that make this pair of compounds? Well, we know they're not the same, again, because the relationship is different. But because the stereochemistry is only reversed at one of the carbons, then they have to be diastereomers. In order for them to be enantiomers, we would have to reverse all of the stereochemistry. And again, this one is the same, while this first one has changed. In part B, we have allenes. Allenes are a name for this functional group where the carbon is bonded to two double bonds on the same carbon. Now, it's not chiral, but interestingly, even though it's not chiral, or the specific carbon is not chiral, the molecule itself is still chiral. And that's one that you can see more easily by building a model. And so if you were to build models of both of these allenes and compare them, you'll find that they are in fact mirror images of each other. But in addition to that, you'll also find that they're not superimposable. And so because of that, that makes them enantiomers. And so allenes are an example of a functional group that it's not sp3, it's not tetrahedral. Because of that, there's no chiral carbons within the molecule, but because of the shape of the molecule, the entire molecule is chiral. In question C, or part C, we have what may look to us to be enantiomers, because in this case we have flipped both chiral centers. But in both of these molecules, we have an internal plane of symmetry. And you can see that if you rotate this molecule. So if you rotate this molecule about that carbon-carbon bond in the middle, got one too many carbons there. So if we rotate it, it will look like this. And now we can probably see more clearly once it's been rotated that we do have this internal plane of symmetry. Because of that plane of symmetry, that means this is a meso compound. And meso compounds, you may recall, are compounds that have chiral centers but are achiral molecules. In fact, it's exactly the opposite situation of what we had in part B with the allene. The allenes have no chiral centers but are chiral molecules, but meso compounds have chiral centers but are achiral molecules. Since these are meso compounds, and in fact they're the same meso compound, then these two molecules are the same. In part D, we have a molecule with two chiral centers. In fact, more than two chiral centers, because this is chiral as well as this. So we actually have 4 total chiral centers. We've inverted one of them, the other 3 stay the same, and so that gives us diastereomers.